Hey everyone, welcome back to the channel. Today we're going to break down one of the most common low-level design interview questions together. For anyone who might not be familiar, low-level design is an interview type that focuses on object-oriented design. So this is things like figuring out what classes you need, how they interact, the actual implementation of the methods that make things work. And so as far as Fang goes at least, low-level design is really common at Amazon, it's common at Microsoft, it's common at Netflix, usually for more junior roles. But it does sometimes show up for senior level roles as well and up. It's also really common in different parts of the world. So much of India and Asia in particular, companies based there or even the offices of FANG companies based out of India or Asia love to ask low-level design questions, oftentimes even regardless of the candidate's level. So what we're going to do in this video is that we're going to walk through one of the most common beginner low-level design questions out there, which is design a Connect 4 game, right? And my hope is that this is going to serve as an introduction to this type of interview for those of you who may be new to it. I'm going to show you both how I would answer the question in an interview, as well as walk you through what I, as an interviewer, would be looking for at each step along the way. I guess really briefly, for those of you who may be new to the channel, I'm Evan. I'm a former staff engineer at Meta and the current co-founder of Hello Interview, where Hello Interview is a platform that helps software engineers just like you prepare for your upcoming interviews. We got tons of content here on system design, ML system design, low-level design, what we're talking about today, code behavioral, you name it, as well as the ability to practice or do mock interviews or have one-on-one mentorship, salary negotiation, basically a one-stop shop for everything you need to prepare for your upcoming software engineering interviews. And the overwhelming majority of all of this content here is free. So head over to the site, check it out. If videos aren't your thing, then don't worry. We have a full written breakdown of the problem that we're going through today, which is going to show you all of the trade-offs, all of the code, all of the decisions, as well as each of the implementations in their respective languages, whereas we're going to stick to pseudocode in the video here today. So that'll be linked in the description. Let's get after it. All right, enough messing around. Let's jump right into it now and actually start designing the system. So that first step was the requirements. And so you can imagine it's early in the morning, you got your first low-level design interview, you're super nervous, you sit down, you enter the Zoom call, and you find your interviewer waiting for you with the following prompt. On the screen it says, build a 2-player Connect 4 game, where players take turn dropping discs into a 7-column, 6-row board, and the first to assign 4 of their own discs vertically, horizontally, or diagonally wins. Right? This is the prompt that you're greeted with. Now, for anyone who maybe hasn't played Connect 4, just really quickly, this is what a Connect 4 grid looks like. Users take turn dropping the discs. You want to arrange all of yours in 4, either vertically, horizontally, or diagonally, right? Now, one of the most important mistakes, most common mistakes that I see, particularly for junior candidates when they start the interview, is they get this prompt and they immediately start thinking about implementation or jumping into implementation. And this is a problem for 2 reasons. First, you haven't spent any time scoping out exactly what it is that you're going to build, so you're not on the same page with the interviewer yet. But second, and maybe equally as important, is that interviewers are actually explicitly evaluating you on what's called your problem analysis. And so they want to see that you can take this vague prompt and you can turn it into something concrete, a concrete set of requirements that you can build against. And so spend a few minutes up front doing exactly that. And you're going to want to ask some questions to clarify this with your interviewer. And what candidates often ask me is like, well, what questions should I ask? And I think the way to do this is to think about 3 primary categories. The first is primary capabilities. So lock down the capabilities of the system. The second is error handling. Determine how you're supposed to handle errors, where errors appear. And then the third is define some scope boundaries. What's in scope and what's out of scope. And so we'll run through this quickly. I don't need to kind of role play this too hard. But for primary capabilities, you might ask the interviewer some questions like, how do players interact with the game? Do they just specify a column number and the disc drops? And your interviewer might say, yeah, that's exactly right. Right? They drop it, it goes to the lowest available spot. Okay, cool. You confirm the main action, right? Then you might say, what are all the ways that a game can end? Is it just the 4 in a row, vertical, horizontal, or diagonal, or are there draws? And this is a pretty good question. The interviewer might say, yeah, that's correct. If the board fills up and nobody gets 4 in a row, then it's a draw. Okay, great. Now we know draw conditions are in play, right? And so we might move on to ask about error handling. This could be things like, when someone tries to drop a disk in a column that's already full, what should we do? Should we return an error, an exception, just ignore it? And they might say something vague like return false or raise an error, but don't let invalid moves break the game state. And then you might say something like, what should happen if a player tries to move out of turn? And they would say same thing, just reject it cleanly. So now we understand where the error states are. Right? You can't drop it into a column that's full. You can't move out of turn, pretty clear. And so then you want to understand sort of where are the scope boundaries of the system. What's in scope, what's out of scope. And so you could ask a question like, are we designing this to support a single game at a time? Or do we have multiple concurrent games going on at once? And maybe if I'm an interviewer, especially for an earlier stage candidate, junior or mid-level, I might say, keep it simple. Let's stay at just one game at a time. And then you could say, what about the UI? Is the UI in scope, for example? And they might say, no, that'll be handled by somebody else. You're focusing on just the back-end class design here. So, excuse me, after this back and forth with your interviewer, you're going to end up with a pretty clear set of final requirements, and you're probably taking notes as you go. And so this is what you'll want to end up writing on your whiteboard. Forgive me, I'm going to copy and paste because you guys saw how awful my typing while you guys are watching is. But you might end up with a final set of requirements that looks like this. I mean, you should write this on your shared screen with your interviewer. And that's that you have 2 players who take turns dropping discs in a 7-column, 6-row board. A disc falls to the lowest available row in that chosen column. The game ends either by having 4 in a row in either of the 3 directions, or it's a draw when the board is full. We know that invalid moves based on our questions are dropping in a full column, moving out of turn, or moving after the game is over, of course. And then we can even outline here the things that are out of scope to keep ourselves honest. If throughout the design we ever try to talk about UI supported concurrent games, well, we know we agreed with the interviewer that's out of scope, so we should try to avoid that. But now we have a concrete set of requirements, and we can start to move on to the next steps in our design. All right, so we got our clear set of requirements in hand. And the next step in our delivery framework is to move on to the entities. This is where we're just figuring out what objects we actually need and how they're going to interact with each other. These becomes the classes in our class design. And so the way that I like to approach this, and I think this is really formulaic and a good suggestion, is to just go through your requirements looking for the nouns, looking for the things that stand out. And so in our case, we have 2 players, okay, we'll probably need to model players, right, that drop onto a board, okay, we probably need a board, right? And then the game ends. Well, clearly there's a game here. There's a game orchestrator, right? So you're pulling out these nouns. Maybe you're listing them as you go. And in our case, what we'd end up with is we obviously have that game, which is responsible for game state and game logic. It's going to hold the board and hold the players. And then we have the board. It's going to manage the grid state, the displacement. It's going to know how to check if columns are full, whether discs should fall, whether 4 discs are connected. It doesn't care about whose turn it is or who's winning. That's the job of game, right? It's just the board. And then there's the player. And this is going to represent just a single person in the game. It's probably going to be a simple data holder with just a name and a disc color. And then maybe there's a disc. Like you could write this, you could not. I think with foresight, we realize this is probably just going to be a simple enum or something. But it is a noun, it is a thing in the game, and it's going to be important. So maybe you want to write it down there. Now, this was pretty simple for this design, but in other low-level design interviews, this can be pretty complex. And so it's worth taking this time up front in order to think thoroughly through this so that you don't end up going too far down the wrong path when you get to your class design. But in any case, you can always come back and you can update this section as you go. Like nothing that you write here in the interview is concrete. It's really just allowing your mind to step into the process linearly so that it's able to build this design up from its foundation as opposed to having to jump right in cold, which ends up usually being a failure state for candidates. So with our entities in place, we got our requirements and our entities, and we can now use those entities in order to move on to our class design. And this is where things start to get more fun in an actual interview. This is where we actually get to decide what data each class holds and what methods it exposes to the outside world. And we're defining its interface, basically. And so something candidates often struggle with is deciding which class is responsible for what. What's the responsibility of the game? What's the responsibility of board, for example? And the most important thing to remember is that each class should have a clear job. And so when requirements change, you should be able to point to exactly which class needs updating without touching the others. That's really the key here. And so for us, when we look at game and board, you can think of the board as just a dumb physical object, like the actual board in the Connect 4 game, right? It sits on a table, it doesn't know about players or whose turn it is, it just knows that a disc can go here, it knows whether there's 4 in a row. Its only job is grid physics and placement rules. And so if the grid size were to change from 6 by 7 to 8 by 8, for example, or the win condition changed from 4 in a row to 5 in a row, only the board class would need to update. And then game, on the other hand, it's just like the referee. Its one job is game flow and orchestration. It knows whose turn it is. Is the game over? Who won? It uses board just as a tool. And if we added an undo feature or a switch to 3 players or any of that, then only game changes. Right? See how clean that separation is? And so the board handles one thing, the game handles another. Neither bleeds into the other's responsibilities. And this principle is important. It actually has a name, and it's called SRP, the Single Responsibility Principle. And it's one of the most important design principles that you'll use, and it applies to almost every low-level design problem that you're going to see. So you don't necessarily need to remember that name. You don't necessarily need to say it in an interview, but it's a principle that you should keep in mind when you get into class design. And it, as I said, shows up in just about every single low-level design interview. Okay, but with that in mind, let's get back to our exact problem here and design these classes. And the way I recommend that you approach this class design is that you start from the top down. So we'll begin with our game class because it's our orchestrator, it's our primary entry point, it's what other users, classes, whatever will interact with. And once we define the games interface, then we can work our way down to the board and down to the player. This will keep us focused on the public API instead of getting lost in the implementation details early. And so for each class, what we can do is we can simply go through the requirements and derive both the state and the behavior, starting with game. So in designing the class design for our game class, we can start by looking up at our requirements and going line by line and pulling out the state. So we're going to focus just on state right now, and then we'll work on methods in a second. So what does the game class need to track or need to know? We have 2 players take turn dropping discs into a 7-column, 6-row board. Okay, so the game needs to track 2 players, a player 1, which is a player, and a player 2, which is going to be a player class. It also needs to track whose turn it is, as well as the board itself. So current player, that's going to be whose turn it is. And then the board itself, which is going to be a board class, which we'll define in a second. And then we have the game ends when either we get the 4 diagonals or the board is full. And so the game needs to track some sort of game state. Like, is it in progress? Did somebody already win? Is it a draw? And so when it comes to tracking state, we actually have an interesting decision to make. I see some candidates who use multiple Boolean flags. This is often like their reflex, is to do something like is over, bool, has winner. Gosh, I'm such a bad typist while you guys are all watching. I'm so sorry. Or is draw, bool, right? And now if you do something like this, the problem is that you end up with 3 Booleans which give you 8 possible combinations, but only 3 of those possible combinations are valid, whether it's in progress, won, or draw. So you can imagine something where it's like is over is true, but has winner is false, and is draw is true. Like, this isn't a valid combination. And so you're relying on yourself or any future programmers or devs that come in here to never accidentally set these conflicting values. And that's bad. And so a better approach, and how you would usually model state in these multi-state games or multi-state designs, is to use an enum with 3 values. And so you could have game state as an enum, which has just something like in progress, maybe, won, and draw. And now you can only ever be one of those 3 valid combinations. Now, importantly, and you guys might be thinking this, if you want to be able to know who won at any point, well, you could go look back at the board to figure it out. That's one possibility. But oftentimes you also want to put that on the player here, or on the game here. And if you do that, well, now you have a nullable player, and you still have 2 things that in theory could get out of sync. Because you could have in progress equals, or you could have game state as in progress, but the winner as a player, that's obviously not valid. You could have the game state as won, but this be null, that's obviously invalid. And so this is a bit more advanced, but there are languages like Rust, Swift, even TypeScript, where you can make the winner part of the one state itself, so that this is actually impossible. But for the interview context, especially when you're writing in pseudocode, this simple enum plus the winner state is more than enough. You'll just have to trust yourself to keep just these 2 things consistent or in sync. And as I said, this is really even just a cache of what the board can tell us about who ended up winning by us just reading the discs on the board. So it might be that you don't even need this altogether. So if you're looking at me and thinking, okay, Evan, that was a lot of talking, like what's right? What should I do in an interview? I hate to break this to you, but there's no right answer. What I want to see from a candidate in an interview is that you can weigh these trade-offs, you can make a reasonable decision and a reasonable justification and move forward. So any of the things that we just described, with the exception of the 3 Boolean states, would be sufficient for me in an interview, and I'd feel pretty good about it. All right, let's come back to make sure that we have our full state. What else do we have? Moving after the game is over, moving after the turn. We don't need anything there. The player gets 4 discs. So looking back at it, I feel pretty good that this is the complete state that we need to model for our game. So once we have our state, we want to then move into the behavior in order to figure out the methods or the actual functions that we're going to need to define. And so we can now look at the actions the outside world needs to perform, and every single one of those methods should correspond to, again, what are the concrete needs within our requirements or our problem statement. And so if we come back here, we have players take turns dropping discs. Okay, so we're going to need some sort of a, I'm going to actually denote these like this, just for private. It doesn't matter, this is a semantics thing, but something I like to do. You can do it either way. And so we're going to end up first, let me put a constructor. You're going to construct the game with player 1, player 2. That's how a game is going to start. Then based on what we just said from the requirements, you're going to have a make move. This is going to have the player making the move and the column that they're dropping it in. And then maybe we either return a Boolean, or we could throw here based on our question that we asked our interviewer earlier in case we try to make an invalid move. We could either return false or have the Boolean. The next thing is that we reject moves that are out of turn, right? So moves should be rejected cleanly if they're out of turn. And so we need to have some way to know whose turn it is. Maybe that's internal, but we have a, why are you trying to give me suggestions? All right, we got the get current player. This is just our getters here, no big deal. And then we're also going to have the get game state, more getters, easy. Get winner, in case we want to return this. Again, this could be by just reading our winner state here, which would be the easiest, or it could be by iterating over the board again and finding which disk won. And then we need to be able to potentially get the board. This would be if somebody wants to be able to render the full view of the board, like whatever person is responsible for rendering the UI. But given that it's out of scope, again, that one is optional. So the most important thing is the constructor and making moves. And then we have a bunch of private methods that'll help us do that. Right? This is the overall class design for game. Now, before I go any further, I want to clear up one common misconception. And I can already hear you guys in the comments screaming and saying, what about UML? And I have a little bit of a hot take here, but I feel passionately that this is an accurate take. And that's that, look, UML is incredibly outdated, and it isn't actually used at any major tech companies. Microsoft themselves actually even removed UML tooling from Visual Studio back in 2006 because usage had basically dropped to 0. You know, an indication that nobody's using it. And so UML was designed for a totally different era of software engineering where you were inspecting, where you weren't inspecting and running code as regularly, or it was more expensive to do so. And as a result, the trade-offs of modeling these in some sort of a diagram in order to help people review whatever was valid back then. It's not now. And so what that means in your interview is that if your interviewer is asking you for UML, then it's either out of habit or some academic training rather than an actual real requirement. And so if it comes up, here's my concrete suggestion to you. Ask them whether a simplified class notation, like we've done here, is sufficient. And in almost every single case, they will say, yes, that's totally fine. Right? In most cases, they are totally fine with it. They also know that memorizing UML symbols is a total waste of time and energy. And so feel confident here. Feel free to tell them that. If they say for some reason, no, I need UML, I personally would probably say, hey, I didn't memorize UML semantics. It's not something I've ever used in my work, and I know that it's actually a pretty outdated form of modeling classes. And if they continue to push, I don't know, it's probably not a company that you want to work at, to be honest, but it's unlikely that they do. So whether or not you need to learn a UML, my thoughts are no, and that what you have here should be more than sufficient. Now let's move on to defining the class design for our board class. We're going to take the exact same approach where we look at the requirements in order to define first the state and then the methods. And as we know, our board class is part of the game state. And so game is going to be who's interacting with this. We want to think about the things that game is going to need to know about our board. Okay. And so we can start looking at our requirements, and we see that we have a 7-column, 6-row board. And so the board needs to know how many rows and columns it has. And so it's going to have rows as an int, it's going to have columns, as an int. And in our case, this is 6 by 7, but maybe it changes in the future, right? So we're just making this extensible here. And then what else do we need to know? We need to know that a disk falls, right, to its lowest available place. That was one of the questions that we asked them. Also, if the board is full, that it's a draw. Also, that if a player gets 4 in a row, then they end up winning. All of this is telling us that we need to kind of track each column in a row. We need to know about the grid state itself. We need to know where the current disks are on the grid. And so this screams to us that we need to actually track a grid. And the question then is, what is the grid made up of? Well, it's a two-dimensional array, of course, but what is in that two-dimensional array? And so what I see a lot of candidates do is they do this. They create a two-dimensional array of players so that you can know which players are in each spot. And I put a question mark here to show that it's nullable, right? For some slots in the grid, there is no player. And this is reasonable. And if a candidate does this, to be honest, I'm okay with it. And it's not the end of the world, it's totally fine. But what you'll notice that this is in part sort of violating that single responsibility principle that we were talking about earlier. And that you don't actually need to know all about the players here. The grid only needs to know about what disk is there, really like what disk color. And so what I like better, and this makes it more testable as well, is that we end up creating a disk color enum, which just has 2 colors, maybe red or blue. And all that the board needs to know is what disk colors are in each spot. And then game can figure out which player that corresponds to and thus which player won and all of these sorts of things. Right? So this makes it more testable. It's a little bit more true to SRP. But like I said, you can go either way. I don't really have too strong of a preference here, but that's what I'm going to end up doing. And so now we can look at trying to define our methods. And if we do this, these are the methods that the board is going, or the game again, is going to need to call. And so the first thing that the game might need to figure out, based on us knowing that dropping into a full column is invalid, right? Or moving out of turn is invalid, moving after the game over is invalid. It's going to need to know, well, can I place this? And so given a column, can I place it? And what should it return here? Well, given a column, can I place it? We'll say that it returns the Boolean. Then game can decide what to do. Return an error to the user, throw, render something in the UI for whoever is handling that. Right? The next thing that we know is that a disk falls to its lowest available row when you end up dropping them. Right? And so we need to have that place disk function. This is when a user calls make move. What do? Well, they check, can they place it? And then they actually try to place the disk. And so this will take the column that they're placing it on, as well as the color. And I'm going to intentionally leave the return value here unknown, and we'll come back to it in just a moment as we learn more. Just continuing to go through here, we know that if the board is full, then it's a draw. And so the game is going to need to be able to make that decision. And so we should expose to the game then is full. It should be able to check this. And that's going to be a Boolean. And then maybe the last one here is that a player gets 4 disks in a row, well then they win, right? And so the game needs to be able to call the board and say, did somebody win? We can call that check win. And so what should check win have? This is where I'll come back to these question marks. Option 1 is that it just has a color. Basically you say check, did this player win? The player with the color red. And if we did this, then we would look at the entire board in order to try to figure out if they had 4 in a row. This is totally doable. It's fairly reasonable and there's nothing wrong with this approach. But what would be smarter is that we know that the only way that they can win is immediately after they place a disk. That's what changed the grid state. So after they place a disk, then whether or not they win would mean that that newly placed disk has to be a part of that 4 in a row. And so rather than checking the entire grid, what we can do is we can tell the game class, right, which row this placed disk fell into. It already knows the column. We can tell it how far it fell in terms of rows. So return the row the disk lands in, or -1, maybe if we couldn't place it for some reason, right, just to handle the error conditions. And then for check win, what we can do is that we can pass in the row and the column of the newly placed disk so that it knows exactly where to sort of fan out from in this grid, checking the diagonals, the horizontals, and the verticals. Okay. And so there's a very strong chance that you did not realize this in class design, and that is so fine. Like in class design, you could have done place this, and you could have had this as a Boolean, and then you could have had this as just a color and a Boolean, and that's great. And as you got into the implementation, you might figure this out, that it would be more efficient, and then you can come back here and make the change. Just given that this is a YouTube video and people might be stopping the video at this point, I want to be careful to just kind of be correct as I go. But no, in the actual game, you can be pretty fluid. And then after here, you have some private methods, sure. The get row, the getters, all of these, get column. I'm not even going to write all of these or put them all perfect, but get cell, whatever. Maybe you want to have these just as internal to the board class, but they'll all be there. What really matters when you're doing the class design is that you expose the public ones, right? The private ones are far less important, and I more or less just put them here for completeness. So anyway, we got our board that encapsulates all the grid math and the wind detection. The game doesn't know how to scan for 4 in a row. It just asks the board and updates its own state accordingly. Now, we've done disk, we've done game, we've done board. We sort of did disk as a result of board because we needed to create that enum. Now we just need to do player. And so what is a player? We're not going to spend any time here. Player is super straightforward. A player just needs to know what color they are, and that's going to be a disk color. And then maybe there's some other things that the UI is going to care about. Obviously, that's out of scope for us, so who really cares? But like maybe it's got a string, and then it's just going to expose some public getters here, like get name, right? Or get color, disk color string. Nothing to it, right? No time to spend. No reason to spend time there. So at this point, we have the class design, and then we can move on to our implementation. Our class design is in place, and now it's time for implementation. So like I said in the beginning, this can be different depending on the company that you're interviewing for. Some, the majority, want pseudocode, what we're going to do. Some want real code. Some want you to just talk through it even. So after you present your class design, just ask them. Ask your interviewer what kind of detail they're looking for. Hopefully your recruiter even told you up front. But as you get into your implementation, here's the approach that I want you to take. I want you to first start by defining, maybe I'll put this as a comment as well. I want you to start by defining the core logic. Right? So this is just listing off in numbers, you'll see me do this in a second, the core logic of the actual function. And then the second is to consider the edge cases. And interviewers love when you consider edge cases, so you want to make sure that this is something that you always do. Right? This is going to be a pretty natural progression. You'll understand what the method should do, and then all the ways in which it could break. And when you get into implementation, typically the interviewer tells you a couple functions that they want you to implement. You don't have time in a short interview to implement everything. And so in this interview, the ones that they usually care about are make move. That's obviously the most important one from game. So game.makeMove. They also usually want to see the board.placeDisk. It's an interesting one. And then check win, because it checks all of those conditions. Right? These are usually in most interviews about this problem, the ones that they want to see you implement, and it's the ones that we're going to implement here together as well. And so as you're implementing, just remember, you're thinking about writing clean code, avoid all the cleverness, avoid premature optimizations. That's a trap that I see candidates fall into so often. But let's go ahead and let's start with our game's make move. And so we have game, and then we have our make move, where make move, if we come back here, took in a player and a column and returned a Boolean. So it's going to have a player and it's going to have a column. And I'm going to come in here and I'm first going to do what we said we should do, starting with defining the core logic. So I'll say, what is the core logic? The core logic here is that we are going to place the disk. We're going to try to place the disk. We're going to check if placing that disk means that somebody's won. If so, or maybe if not, then we'll check for a draw. And then we will switch turns. Right? And then we'll return. So that's the happy pace. When somebody wants to make a move, we just place the disk. We check if they won. If they didn't, we check if overall there's a draw. We switch turns, and then we return. I don't even need to add that. And then what are the edge cases? Where can things go wrong here? Well, the edge cases would be what? That the game is already over. You can't place a misc then, or you can't place a disk then, right? It could be that it's the wrong player's turn. That won't work. If the person trying to place it, it's the wrong turn. It could be that the column index is out of bounds. They're trying to place it somewhere where it can't be placed. It could be that the column is full. And so if you're watching this and you're astute, you might be thinking to yourself, wait a minute, Evan, those, based on what you said about single responsibility and proper encapsulation, those should not even be a part of game. And you're right. So I'm kind of going to note that to myself. This is actually board. Right? I'll make sure that board does these checks. But as it pertains to game, game just needs to know whether its state is already over or whether it's the wrong player. And so we can come in here then to try to actually implement this. And what would it look like? Well, I'm going to start with just the happy case. So I'm going to place a disk. So I'm going to say board.place disk, and it has a column, and then we know that we have the current player, but it takes their color. So I'm going to do that. And then what did place disk return? Place disk we said would return the row. So I'm going to say row equals that. And then I'm going to say if board, and this is just pseudocode. You can write pseudocode however you want. You can see my pseudocode looks Python-y, but it really doesn't matter, right? Do whatever works for you. You're just trying to get the logic across to your interviewer. No interviewer cares about the type of pseudocode you write. There is not even an agreed upon style of pseudocode in the industry. So I'm going to do board check win on the row and the column, right? I have the column because it was passed in as a parameter. I have the row because we returned it. Remember, that was a decision that we made earlier. And if that's true, then I'm going to change the state to 1. And I'm going to change the winner to the current player. Cool. What's next, though? If it's not true, we said that we need to check if this was a draw. So I'm going to say else if the board dot is full. Well, in this case, my state equals draw. And then otherwise, right? So if we won, game over. If it's a draw, game over. If it's not game over, then I need to switch my current player. And so my current player would be that if the player equals player 1, then now it's player 2. Otherwise, it's player 1. Just a simple ternary there, right? I'm just saying if it's player 1, now it's player 2. Otherwise, it's player 1. No big deal. And then maybe at the end here, I return true because we said that make move returns a Boolean as to whether or not we were successfully able to return, or we're successfully able to make the move. Okay, so that's my happy path. Easy, relatively easy, nothing to it. Let's now think about those edge cases though. And so what are the failure conditions? Well, if the game is already over, and so I need to say if the state does not equal in progress, then we should return false. And then if what did we say? If the player does not equal the current player, and we have current player as state, remember, current player as state. So if the player does not equal the current player, well, I'm also going to return false. But then I said that I was going to offload these to the board, and so I'm assuming that place disk is going to return -1 if there was a failure here, if it was unable to place the disk. And so I should check that. If row equals -1, there was a failure, we weren't able to place the disk, and I'm going to also return false in that case. One important thing to discuss here, and some of you might be thinking about this, doesn't this stink? Why are we returning Booleans? Shouldn't we be throwing errors? And like, you're right to call that out. You're totally right to call that out. In this case, whoever's working with the UX or the UI is going to they're not going to know what type of error this was. They're going to just say to the user, like, there was an error. And that's maybe not a great experience. And so because we defined that as sort of out of scope, and this is an interview, and I'm kind of shortening things here, maybe this is fine. But if you want to be totally complete, and I would appreciate a candidate bringing this up, then maybe you actually return some appropriate error status here. Like maybe this returns some object that has like success and message. And in each of these, you can actually then return false and, game not in progress. Or maybe it returns an enum so that the user knows or the caller knows what to do with it. The reality is you don't know what the caller wants here. And so I would just raise this. If I was an interviewer, I'd raise this to my interviewer. I would say, I know this is important. I know it could be something else. I've sort of taken like a cheat code here by just returning false or true because I don't know what my caller wants, but it would probably be some sort of an informative error message. And they would appreciate that. I think that's more than enough for them. But ask them, see what they say. If they want the full error states, you can obviously put them. So just reviewing this again, our core logic is in place. We place a disk, we check a win, we see if it's full, and we switch players. Our edge cases are handled, game over, current player, as well as any issues with the columns being full or the wrong index. This looks like a pretty good implementation of make move. We can move on then to the next key function that we want to have a pseudocode implementation for. This is going to be from our board class, and it's going to be place disk. So we can scroll down here, class board, and then we have place disk. And if we look up at our class design, we can remind ourselves it takes a column and it takes a color, and it returns the int of the row that it landed in, or -1. So we have the column, and the color, okay? And so we'll take the exact same approach. We'll just define what the core logic should be, and then we'll define what our error conditions should be. And so the core logic here is that we want to find the lowest empty row so that it can, for that column, so that it can fall to the lowest empty row. And then we want to place the disk, basically update the grid state, and we want to return the row it landed in. So we know where to span our check out from, as we talked about earlier. As for edge cases, these should be the same as what we have here. We already determined that they were edge cases a part of the board, right? So the edge cases are the column index is out of bounds or the column is full, okay? So if we then come in to try to implement this, we can start with our core logic. And the first thing, when it comes to finding the lowest empty row for that column, let me paste this ASCII in it so I can help you guys visualize this. This is our grid, right? So we just have a grid, an array of rows, okay, where each one of these is indexed at 0, so 0, 0 is our top left-hand corner. And so if somebody told us they wanted to drop it into 2, well, what we'd want to do is we want to check here, then here, then here, then here, then here, then here, all the way up until or if we found an empty one so that we could actually place our disk. And so that means that we start at the rows minus 1, because remember, rows was one of our state variables that in this case is going to our instance variables, which is going to be 6. And so we start at rows number 1 since it's 0 indexed, and we just work our way up. And so in pseudocode, what that might look like is for row, where rows, row equals rows minus 1 down to 0, just have a for loop of that nature. Right? Then we can say if the grid, and we do rows first with that row and that given column, which was the input, if it's null, then what we want to do is we want to set the grid with that row and that column to the disk color that was input, right? And we want to return that row. If we don't, then maybe we return -1. So there's our happy case, pretty straightforward, core logic, nothing really to it. Now if we look at those edge cases, then we could either just kind of offload this, and we probably will end up doing that. Yeah, let me do that. So I'm going to say if the column is less than 0, or the column is greater than or equal to board.getCalls, right? Then in this case we can return our -1. And then what's the other condition? Well, if the column is already full, and so that's the logic that we can just offload to the helper. We already had a helper about canPlace. So if you remember, we can just have if board.canPlace column. And this is really useful to do this kind of offloading in a low-level design interview. Not only is this like correct, right? It's nice to have designs that are simplified in this way. It's like correct programming. But it also just means that you don't have to now go implement that class or implement that method, that function, unless your interviewer asks you to. It's basically you saying like, this one is easy. I don't really need to do this one. If you want me to, I will, but I can kind of just place it that simply. So with that in place, we have our core logic, easy enough, right? We work from the grid all the way up until something is available and we place it. And we return these -1s or errors, as we discussed earlier, based on our 2 edge conditions. Last but not least, we can implement what is really the most interesting function maybe here, board.checkWin. So if we come back to our board, we can do checkWin. And what did checkWin take according to our class design? CheckWin takes the row, the column, and the color. And so the row and the column, this is the disk that was just placed, because again, we can just fan out from that disk that was just placed rather than looking at the entire board, and the color. And so here, excuse me, again, we're going to define our core logic, and then we'll define whatever edge cases we need to be aware of. And so for our core logic, we just need to check for 4 in a row, in all 4 directions. And you might think 4 directions, don't we just have horizontal, vertical, and diagonal? Well, there's 2 diagonals, right? Because you can win horizontally, you can win vertically, and you can win diagonally to the right and diagonally to the left. And so there's actually 4 there, and that's important. And then obviously, we're going to return true if found, false otherwise. So that's the core logic. The edge cases would be if either row or column becomes out of bounds, or the one given to us is out of bounds, then clearly we would return false. And if you ended up giving us, 7, column 7, row 6, it's out of bounds, nothing we should do with that. What if they gave us row and column? What if this was blue and they gave us row and column 3, 5 or 5, 3, and it wasn't blue here? Well, we should return in that false in that case too, right? So if the cell at row column doesn't match color of the disk, then also return false. Those are our two edge cases, error cases that we want to handle. So let's go ahead and now implement it. This is the more interesting implementation of all of these. So the first thing is we want to figure out how we can check the wins in each of these directions. And so what that means is that we're going to start with a disk. That disk could be placed here. And what we want to do is basically count how many of that same color are to its right, how many are to its left. For vertical, how many are above it and below it. For diagonal, how many are up and to the right and down and to the left. And for the other way, up and to the left and down and to the right. And then we're going to sum those up and see if it's 4. And so what we can do is we can define first the directions that we move. And so the first thing that we would have is that we could move 0 in rows, but 1 in columns. And that would mean that we are going over horizontally. We're staying on the same row, but we're moving 1 over on the column, right? So this would be that we've gone over 1. Maybe let me do this to be clear. So this would be a horizontal check. Right? And then we can also have 1, 0, and this would of course be the vertical check, right? Because this would mean that if we're right here and we went over 1 row, we went up 1 row and we didn't change columns, well, we're checking vertically then in that case. And then we also have 1, 1. This would mean that we go up and to the right, or I guess in our case, because we're increasing, this would really be down and to the right. So this would be the, what did we call this? Diagonal, is that how you spell it? Right. And then you need to have the other diagonal one, which is basically you're going in the other direction, which would be that. So other diagonal. So those are our directions. Those are the ways that we need to move, but we also need to move like the opposite of those. So again, if the disk is here, then that horizontal one is going to take us in this direction. We also need to look over in that direction there, okay? So let me show you how we can do that. So we can say that for all of the directions to the right, or the directions of the row that we should move, and the directions of the columns that we should move in directions. So we're going to iterate over this. The first time that we iterate over it, we need to move our row by 0. We need to move our column by 1. Okay, you can see how that's happening there. We remove that for better pseudocode. And then our count is starting at 1. And then our count is going to increase based on our count in that direction, starting at the row and the column that we're currently at, moving up by the amount that we need to for the row and the amount that we need to for the column, checking for that color. And so this is move in one direction. In the case of our first horizontal one, this is like moving to the right, okay? And we're gonna implement this function in a moment, but we're gonna offload it for a second. And then we need to look in the other direction. And so we can do this same thing. Right? Count in direction. But in this case, we want to go in the opposite direction. And so in the case of our horizontal check, this would mean that our column is actually -1. And so we're looking this way. So our first check is going to move to the right, count how many are to the right. Our second check is going to count how many are to the left. We're adding those to our total count, starting with the disk, which we already know is the right color. And then if the count is greater than or equal to 4, then we can return true. If we got out of this whole thing and we didn't find it, then obviously we're returning false. So that's the high level, but in order to make this make more sense, let me go ahead and also implement what would be a private method here of that get direction. And so that's get row, get column, the direction that we need to move in the rows, the direction of columns, and then the color here. And so you have your count starting at 0. How many do you have? The row that you need to check now is whatever the current row was plus, how much we need to move. Either one step in either direction or 0. Oh. The column, same thing. Column plus our DC. And then what do we check? We just check if the row is greater than or equal to 0, this is just our simple bounds here that we always need to check that we don't go outside of the grid, and our row is less than the board.getRows, okay, easy enough, just did we get outside of our bounds, and C is greater than 0, C is greater than or equal to 0, because 0 is in play here, and the C is less than board.getColumns, right? Just again, are we in the board? And then most importantly, that the board.getCell that we're at of this R and C, the one that we moved to, right, equals the color. So if all of that is true, then we are still in the board, we haven't exceeded the board, and as we moved over 1, we are still that same color. And as a result, we should increment the count, and we should also then move over once more, right? So we can move our column, our row and our column by 1 more each. And at the end of that, we can return our count. And so what is this doing? It's starting where we need to be, and it's just walking its way over in just one direction, because we define that direction that it needs to go. And so the overall one does this twice. It first walks over in one direction, and then it walks over in the other. So in the case of the diagonal, it walks that way, and then this way. Sums up those counts if they're greater than 4. Hoorah. Okay? So that covers the core logic. And then the edge cases, of course, our row or columns are out of bounds. Well, we should probably just check that right up front. I'm going to copy this because it's the same code. And that's just if it's this, then I'm going to return false. And also if board.getCell of that row or column does not equal the current color, as we said in the second check, then I'm also going to return false. Now the thing that I want you guys to see here is not watch me write code. I actually hate that you guys are sitting here watching me trying to just type this. The interesting thing is I want you guys to see how systematic you can make this in an interview, right? How easy this can be by just going step by step. If you've built your class design, you understand the functions, you understand the core logic and the edge cases for each, then you can come in here, implement that core logic, you can implement the edge cases, and everything becomes pretty straightforward. One other thing that I want to call out here is that some of you are probably thinking to yourself, why didn't he use the strategy pattern? And I break this down in more detail in the article, which is going to be linked in the description. But let me paste actually what the strategy pattern could look like in here for you guys. Unfortunately, this is in Java, but I think you guys can still get the picture. What I see a lot of candidates do is that they implement some interface of a win checker. And that interface has one function to check. And then they implement a horizontal win checker, a vertical win checker, a diagonal down, a diagonal up, right? And in their check win, what they do is that they have all of those checkers, and they iterate over each of them, checking them, and if any of them return true, then of course the check win should resolve to true. And so I didn't even implement these, I stubbed them out. But you can see how many lines of code this is. And I think this is a classic example of something I see in so many low-level design interviews, and if you take anything away from this video, maybe it's that I want you to take this away. That the most common mistake candidates make is that they just shove patterns unnecessarily into problems because they want to show off to their interviewer, look at all these patterns I learned. And what it leads to is just ridiculous over-engineering. Like, why do I need to define an interface and a strategy pattern for each of these 4 strategies when A, there's no conceivable additional strategy that you could have. There's no other direction that you could even move on a grid, first of all. And B, in order to check this, it's just 10 lines of code. Why blow everything up like this? And so maybe this is kind of my own itch that I'm passionate about, but I think that this is strictly speaking correct within software engineering. And it's a symptom of these low-level design interviews where we've taught these patterns in object-oriented design so excessively that candidates actually lose sight of what they're supposed to really be doing. And so don't be that guy or girl. Don't shove patterns in just to show the interviewer that you're right. If you want to show them that you understand patterns, do this. This is a senior level thing to do. You could say here, hey, I could introduce a strategy pattern here. I could have a pattern, or I could have an implementation for each of the different check directions, and then iterate over those check directions in order to determine whether someone is one. But the reason I'm not going to do that is because there's no really conceivable option for those win checkers to change, and their logic is all so similar to each other. And so there's no reason for me to blow up the complexity of this implementation just to fit in a pattern unnecessarily. If you say something like that, your interviewer will be impressed, I promise you. And if for some reason your interviewer is not, and they say, no, I want to see you shove a pattern in here, then so be it. You can go ahead and you can implement the pattern. And again, I don't know, it's not the best interviewer, maybe not a company that you want to work for. But I also understand that the market's tough and you need to adapt, and we all want to get those jobs. But nonetheless, there's the implementation of the 3 core functions. If you want to see these implemented in your language of choice, or you want to see all of the smaller helper functions implemented as well, again, written breakdown, you can see all of that there. If time permits, and depending on your level, your interviewer might now ask you a couple follow-up questions to test the extensibility of your code. Depending on the company, as I said, level, how hard the question was, you may not get here. And I know this video is already pretty long. And so especially if you're junior, mid-level, feel pretty good. Like you've gotten to this point, you're all done. If you're senior or up and you want to stick around a little bit, I'll be complete and just walk through what the top 3 extensibility questions for this particular low-level design interview usually are. And that's how you'd support different board sizes, how you would add an undo or a move history, as well as how you would add a computer opponent. So if we start with just that first one, this is really straightforward. How would you support different board sizes? If my interviewer asked that, I would say, well, that's actually really straightforward. Nowhere aside from in the class definition would we have hard-coded our 6 and our 7. Haha, 6, 7, yeah, whatever. So all that we would do is add this guy. I actually just added it, and this wasn't here a moment ago, but a constructor which takes in our row and our columns, and as a result, now we have a dynamic board size. It can be whatever you want it to be, because nowhere else in the code did we hard code that 6 or that 7. Right? Everywhere we dynamically checked based on the number of rows and the number of columns when we were checking boundaries. So our grid would just naturally grow and everything else would work. Perfect. Our code was extensible. So my answer here would just be update the board constructor to take any, and it'll work. And it'll work. Easy. For that next question, how would you add undo or move history? Then this one's a little bit more involved. Undo is pretty common. It's a pretty common follow-up question for these sorts of games. And this is testing how well you had a clean separation between your orchestrator, our game class, and your state or your board class. And since all moves are flowing through that game make move function, you already have a single choke point where you want all of the moves to be recorded. And so you need to introduce some history. I would basically say something along the lines of this. I can add it here. This is just directly out of the written breakdown, which is linked in the description. So I would say undos belong in the game because game controls the lifestyle, the turn order, and when state changes. And then I just keep a move history stack such that each time a move succeeds, we push a small move record containing both the player, the row, and the column. And then when we want to undo, we just pop that last move off, we clear that cell on the board, and we revert the current player. This is essentially what would need to happen. So let me show you just quickly what that might end up actually looking like. And so we would have to add a new class, like a move, which just tells us the player, the row, and the column that actually took place. And then within our game class, we would add something like this. If we come back up to our game class, right, we would add something like a move history. We would add something like a move I put that in the wrong place. We would add something like a move history, which has a stack of those move objects. And then within make move, we're going to push to that stack. Okay, let me remove it just because I'm going to link this and I don't want you guys to see the kind of incomplete state there. But what that would end up looking like is that in terms of changes, we'll have game with that. And then when it came to that make move function that we had earlier, it's going to now look like this. All the things we did before. Remember, we placed the disk, and then we're going to push that new move onto the move history. And so then what the actual implementation of undo last move would look like would be as straightforward as this. We would say if the move history is empty, obviously return false. That's our edge condition. We'd pop off of our move history in order to get the last move. And then we could revert the board to clear its state. So board would now need to expose some clear cell, which just takes the last row in the column and obviously removes that cell. It would probably check, like, are there cells above me? Can I even remove this? It probably has some condition checks there, but we won't go that deep. And then simply change the current player. This could be that ternary like we had earlier. Or actually, no, this is even better. Right? We have the last from the move, so we can put the player back. and then put the state back to where it needs to be, something like this, in case there was a winner. This is a simplified version, and to be honest, this is all you would need in an interview. Usually when they're asking about extensibility, there's no time left. They're not wanting full implementations again. What I did here is probably even more than you would want in an interview. Like, it would be sufficient to just say this, right? Read this thing out. That's kind of good enough. But I wanted to just really show you guys a little bit more about what I meant here, so I was a bit more complete. And then last but not least, we have that, how would you add a computer opponent? And so this one's a little bit interesting because it's mostly outside of the state or outside of the scope of our current design. And what this follow-up question is usually testing is whether or not you can extend this behavior and recognize that it's outside of your current class design. So without like ripping up your game and your board implementation as it is. So you might say something in effect like this. Let me again paste this in. You might say that you'd keep the game rules exactly as they are, game and board, nothing needs to change. You just introduce some small bot component or bot class that looks at the current board and then returns whatever column it wants to use. Now, we didn't kind of do this game drive logic. That was outside of our scope. So the current game drive logic would look something like this. Would look something like, would look something like this. You would have while the game state is in progress, get the current player, and then their column equals, wait from the UI to get input. Basically, this is how the game would progress. You just go back and forth between the current players, you would get that input, and then you would do game.makeMove current column. This is how our game class would be used or called. And again, something like this. This would be sort of the drive engine. And so the only thing that would change here is that maybe you would create some class bot engine, which has a choose move. And how it chooses the move, your interviewer doesn't care, nobody cares. Like, obviously you could have some sophisticated ML thing here, or you could just randomly choose a column on the board. It doesn't really matter. But then the only way that that little thing changes is it becomes now this. And so now when you instantiate the game, you also instantiate this bot, and you simply say, if the current is a human player, then do it from the column, else choose the move from the bot, and you go from there. Your actual board and game didn't need to change at all, and that's sort of the key here. If I ask this follow-up question, one thing I see candidates often do is that they'll lean into like the object-oriented heavy approach, and they'll create a player interface. They'll create a player interface, and it'll have a human player, and it'll have a bot player, right? Where the choose move for the human player reads from the UI, and the choose move from the bot player chooses it, however we decide to choose it, randomly or otherwise. This is fine. I don't mind this. I think that this is totally okay. I don't know. I'd argue that maybe the simple bot engine approach that we have here is even a better design, just because a human player doesn't do anything. It's just data. And so making the player an interface adds this abstraction without actually adding any value, whereas keeping player is just a simple data and separating its identity from making decisions makes, I think in my mind, pretty clear. And if you had reason to believe that there would be other types of players, a human, a bot, and what else? I don't know. I can't think of it off the top of my head. But in any case, I appreciate either approach in an interview. As the interviewer, I don't mind one bit. So feel free to do either one. All right, there you have it, folks. We've walked through each of the steps in the framework all the way through to extensibility. Hopefully you feel like you have a pretty good understanding of how you would answer this question, and more importantly, the framework that we would use to walk through low-level design interviews of any question or any problem in the future. The main takeaways I want you to have is that these interview types don't have to be so daunting. When you build up sequentially and you follow the framework, it really follows a natural progression that's easy to build off of. And so long as you remember to keep things simple, to not over-inject patterns in order to show off in places where they're unnecessary, I think you're gonna do a fantastic job in your interviews. So this was the first low-level design interview that we've put on this channel. Let me know what you thought. Let me know if there was anything that was confusing, or if you don't like the flow or the progression. Anything, any feedback, any tips. We'll continue to evolve these to make them as useful as possible for all of you. And most importantly, best of luck with your upcoming interviews. You guys are going to do great. Take care.